everyone. Good afternoon. How is everyone? Is that your fourth deep dive? Do you have content coming out of your ears? Do you have enough coffee to stay awake for 3 hours? Okay, I'll walk, same as when I'm giving a class. I'll walk behind you slowly like this, and I say, wake up! See if you come up with something. So hi, everyone. I'm Daniel. I am an engineer at Broadcom. So in the Spring team, I am in the Spring commercial org, where we do applied Spring. So we take Spring open source libraries, we build products with them, and then we sell that to our customers. But I also do a lot of open source, focused, as you may have guessed by the title of this presentation, on security. So if you are very frustrated with your Spring security configuration, that's us, that's me. And these days, everybody's doing AI, so I'm doing AI as well. I am doing security for MCP servers. So we can talk about that after the conference if you want as well. You can find all my socials. So I'm on Blue Sky, I'm on the internet, I am on GitHub, LinkedIn, email, and I'm here physically at a conference with you. I come here to show you a few things and then chat with you. Learn from you, get your feedback, get your use cases, understand how you're using our libraries and what could be improved. So please, if you've seen me in the hallway, even if I'm pretending to work on my laptop, you can come to me and chat with me, and I'll be very glad. If you don't have the chance to be here with us today and you're on YouTube, like and subscribe, and then send me an email if you want. I'll take the time to answer, even though it might take a little while. So this talk is about authorization, roles, and permissions in Spring Security. And it's a follow-up to a 2022 talk I did, so 3 years ago, here at DevOps Belgium. Anyone was in the room for that talk? One person, 2 people, woo! So this was 3 hours as well. And this talk is kind of the introduction for this one. So you must now all go and watch that one. I will do a reminder of what we discussed in that talk. But it will cover, this talk covers authentication, so the identity of the user and so on, whereas today it's about permissions. If you go watch this one, you'll see it's Spring Security 5. And today we're at Spring Security 6. And next month, it's going to be Spring Security 7. So every 3 years, I come and make a talk just before we make a new release. Amazing. If you want to see the same one with Spring Security 6, but short format, I did one at Spring I/O as well, so 45 minutes. It's this one is for when you go to bed and you can't sleep, you put that one on. But then if you want the content, maybe you look at that one instead. So, program for today, we're going to do a demo app. I have a skeleton of an app, and then we're going to be adding stuff, to get warmed up, to discuss the concepts of authentication and authorization. And then we'll talk a little bit about authentication, because authorization is about the permissions, and oftentimes in the permissions there's the identity of the user which must be known, right? To let you in, I must know who you are first, right? Then we'll take quite a moment to discuss what Spring Security has to offer in terms of authorization tooling. So all the things for permissions in Spring Security. Then we'll talk a little bit about the internals, how it works under the hood. You'll see it's very simple, but it might be surprising if you don't know how that is wired up. And then the last part of the conference, we're going to focus on designing your authorization system. So designing your roles, your permissions, your attributes, and so on. Because the tooling is fine, it's cool, it's tech, it's exciting, but it's like giving you a hammer and power tools and and a saw, and then teaching you how to use those, and then tell you, go build a house. I can't build a house just by knowing how to use some tools, right? You need some patterns, you need some ideas of how this works. And so this number 5 is what we're going to cover. And then we'll talk a little bit about testing, not too much. We'll see how much time we have, how many questions we have during the talk. After each section, I will take a break with you and then take your questions. So you don't have to wait for 3 hours to ask me your questions. All right? Okay, so demo app always starts with a demo. So I have an application, simple Spring Boot application. It has a few stuff in it already. You know, it has a controller, and it has a repository, and it has, you know, a domain object. It doesn't really matter. It's a simple thing. I saw some breakpoints in here. Where is that? Controller. Remove breakpoints. Break. So, and importantly, I have already imported Spring Security. So to import Spring Security in your project, you know, Spring Boot Starter Security, or as Josh would put it, you go to start.spring.io, you zoom in, and then you add Spring Security. With this, you have Spring Security. You'll notice when you do this, it gives you Spring Boot Starter Security for your production code, but also a dependency in the test scope. So we also have some testing tools that come in. So you have these two things when you start your project. So it's running. And then if I try and access an endpoint on that app, it redirects me to the login page. So this is the default behavior when you add Spring Security. We add a user, Spring Boot adds a user for you and secures everything. So if you try and access anything, so if I try and access foobar here, it doesn't exist in my app, I get redirected to the login page. I need to be logged in to know that foobar even exists. Same if I try and do it with, you know, curl, right? HTTP, AT-AT, security is easy, not, right? If I try and do this, I get HTTP 401 unauthorized because I'm not passing my credentials. So to log in, the default user is very surprisingly called user. And their password is in my console in here, right? So in here, I have a little thing that says using generated security password, and here's the password that Spring Boot generated for my user. Fine, I put it here, and then I can go. So now I'm going to foobar. Foobar does not exist. I get 404, but I should be able to go to the main page, be logged in like this, right? So in here, you'll see it says it's a generated password. This generated password is for development use only, right? Do not put that kind of configuration in production. It's just because we want you to be able to do something with the app, even if you don't have a security configuration. But we want a security configuration. So let's do this. We want this public page to be public at least. So to do a configuration in Spring Security, anybody uses Spring Security here? Woo! 90% of the room. Anybody likes using Spring Security here? Yay, 15%. That's why I'm here, to make you like it. So to configure Spring Security, you create a configuration class, often called security configuration, but you know, if you want to call it, I don't know, DevOps is fun, that's fine. So it's a configuration class. You do enable web security. So Spring Boot does this for you. I like putting it to be explicit, but Spring Boot will do it for you. And you produce a bean of type security filter chain, called security filter chain, fine. It takes a builder object, which is called HTTP security. And so since it's a builder object, we build it. Build, here we go. So it can throw an exception. And then we can add some rules. So we can add rules, say, well, authorize HTTP requests, which is going to say things about permissions. So we said, for example, that our main page, auth request matcher, so the slash page, anyone can access it, permit all. And then maybe we do the same for my CSS, because my site is pretty, it's beautiful. So I need this, and probably the browser is going to ask me about favicon, sure. And then maybe I want to show the error page as well, because the error page in Spring is delightful as well. And then anything else, so any request, I must be authenticated. So I must be logged in to see that page. So if I do this, and I open a incognito window, now I can go to the public page, no problem. If I try to go to foobar, though, it will reject the request. It says HTTP 403 forbidden, because that's what we put in our configuration. So our configuration overrides what Spring Boot gave us. And so by default, it says, no, that's forbidden. We're missing the form login, so we can turn that back in. Form login with defaults. Here we go. So now, if I try and go to foobar, probably build. If I try to go to foobar, oh, I'm logged in here. Localhost foobar. Here, then I see the form login again. So I should be using, the user, and the password that's changed, right? Since we've seen it in here. The app has restarted many times, and now the password is different. I don't want to be bothered by this. So if you're doing a demo, you can go in your application YAML or application properties, and you can put Spring security user name Daniel, like something like that. But I want more interesting users than this. So I made my own user object called demo user. I have coded it in advance just because that's a lot of code that I don't want to be demoing. So the user has a username and a password, and they have roles, basically. And they have an email. That's the new thing. So Spring Security has some users. It has a user class in here, and that user class has password, username, and authorities, and a bunch of things that tell you, oh, is the account locked, and so on, but it doesn't have an email. So the email is my business logic. That's what I get paid for the email. So to provide these users, we are going to go to any configuration class, but I'm going to put it in the security configuration, and we provide a bean of type user details service, and return. And then here, depending on what you do, maybe your user's there in a database, so you have a JDBC user details manager, or maybe you have in-memory users. So I have my own implementation because I have my own type of users. So I have a demo user details service that takes demo users. So I have a demo user. Now, that demo user is Daniel. They have a password. Very secure, very secure. Take your phone out. That's my password. And then an email, example.com, right? And then some roles. So list of, and so let's say Daniel is going to be a user, a normal user, and a speaker, right? And we need a few more users to make authorization decisions on those. So I'm going to have Josh. And Josh, he's a user, he's a speaker, but he's also a rock star, and an admin. That's our admin, Josh. Then we have Alice and Bob. And the difference with Alice and Bob, they're regular users. They're not speakers, they're not admins, they're not rock stars, but they have different domains. So Alice is a corporate executive, so she's in corp.example.com. And Bob, our friend Bob here, is external. He's a poor contractor. So he doesn't have access to the NAT room in the company. And he has a different email, bob@ext.example.com. And that's it. So with this, these are my users. And here, log in with an HTML page, username plus password, right? Okay, so now let's go back to this, and then I'm probably going to log out because I logged in already. Fine. Okay, so go back to the public page. I want to go to the private page. So I try and access private. Spring Security tells me you're not logged in, you're not allowed. So I should log in, sure, Daniel PW, and then I get logged in. So here's my private page. I've prepared it with a bunch of few examples of rules that we're going to add. Oh, here's Dimitri. Oh, come here, Dimitri. Come here. I didn't expect that in the beginning. So give me a second. Do you know Dimitris? This guy. If you've seen beautiful photos of Devox, then that's this man here. Appendix. This guy. You never see him because he's behind the camera. And he makes astounding photography. Go check it out. It's beautiful. He's responsible for this one. So this was not prepared. He just came in the room, I grabbed the balloon and started bouncing it, and here's this guy. I wish my code was as good as his photography. It's not the case. But, do you know what? Secretly, Dimitris is a programmer. So here's another picture of me, this time at a different conference. Why Dimitris again? Do you notice anything? Look at this. Look. Here. Can you see it? Yeah, right? There's a picture of me by Dimitris in front of a picture of me by Dimitris. So I think he understands recursion very well. And so I think we should go one level deeper, right? So Dimitris, tell me, where should I stand? So I have a picture of me, in front of a picture of me, in front of a picture of me by Dimitris. Where do I do this? Here? This one? It's beautiful, isn't it, right? This guy, these pictures. Mwah. Thank you, man. All right, thanks. A clap for Dimitris. All right, where were we? Security. Poof. Who cares about that? All right, so we were doing security, login, username, password. Beautiful. And now I can log in as Daniel. So I have my Daniel here, and I'm going to open a different browser. My favorite browser, Safari. Okay. And so in Safari, I can log in as well as Josh, because I want to be an admin. So Josh has a secure password as well. Here we go. So we have Daniel on the left, Josh on the right, and you have a little header here that tells you the roles of these users. So Josh is admin, Daniel is just a user and a speaker. That's me. I'm a 1x programmer, Josh is 10x here. And so I want to start implementing authorization decisions based on the users. And so here's an admin page. And for now, there's no special rule. So any request you remember, you must be authenticated, and that's it. I want to change that. I want this page to be available for admins. So I don't want Daniel to be able to see it. I want Josh to be able to see it because Josh is admin. So that's fairly easy. If you've ever used Spring Security, you know how you do this, right? You do your authorization here, request matchers, admin, that's the admin page. And then here has role, and then you say admin. So must be admin to view the page, right? So when I refresh my page here, Daniel has a very, very sad HTTP 403, forbidden, but Josh is still an admin, and so Josh can view the page. So here we're doing authorization level security, or request level authorization. So we have a request, and we say it must match this condition. There's another way of doing things in Spring Security, it's securing methods. So we're talking at the HTTP request level, but we can also look at specific methods and then implement rules on them. So on my page, in here, at the bottom, I have shipment information. So I have 4 shipments in my database, very, very real example. And I want only admins to be able to know what the shipment count is, right? So Daniel should not be able to see that. So to see this, I can look at my controller, my demo controller here, and it has that private page. And to see the number of shipments, it calls shipment.count. So I want to secure this method here, this count method in the shipment repository. So in our security configuration, we start by enable method security. Right? So Spring Boot does not do that for you. You have to do it manually. So that means now in the repository, I can annotate the method and say add pre-authorize has role admin, like this, right? And so with that, if I recompile, then Josh is fine. Oops, good, right? Josh can still see the page, but then Daniel is calling the app is calling shipment.count with Daniel. Daniel's not admin, so I get an HTTP 403. Not great, right? It's kind of ugly. So we would like to show the page instead of showing 403, and we see that's an authorization denied exception. So we could see, well, who calls this? It's the the controller here. So we could wrap this entire thing in a try catch. Come on, wrap try catch. And so when we have an authorization denied exception, we ignore it, right? This is fine. Fire. Here we go, right? This is fine. So if I am allowed to call this method, then I'll put some value in the shipment count on the page. Otherwise, I don't put anything, and so the page renders nicely. So now Daniel can see the page, but he has no shipment information, and then Josh can see the page, can count the shipments, and so can have this extra very sensitive information on the page. All right. So 99% of you has used Spring Security before. So you've all done this before. It's very simple. You've added some authentication mechanisms, so some login. This time we used form login, but maybe you used, I don't know, X509 certificates, MTLS. Maybe you used LDAP for you, or maybe you used OAuth2 login with OpenID Connect. And then you added some permissions, either at the request level or at the method level. One thing to note here, which is an important philosophy that we want to have in Spring Security regarding authorization, is the separation of concerns. So our security configuration here, this is not your business logic. This is just authorization code. So it's in a special place on the side, not mixed with your business logic. Same goes for the shipment repository here. Inside the method here, look, no security here. Nerd. Right? The security is an annotation on my code. It lives outside. Well, there's this kind of this is fine. So here I'm handling inside my controller, I'm handling an authorization denied exception to do, okay, maybe this is not great. Fix later. We'll look at this later. But for the rest, it's fine, right? It's separation of concerns, authorization is outside. So we're going to look at how authorization works. But before we do that, I want to do a refresher for the 99% of you who were not there at my first presentation. I am very, very sad. So Spring Security produces authentication objects that represent the logged-in user. So authentication is an interface, and it contains two important things for you in the case of authorization. The principal, which is the identity of the logged-in user, or the identity of the robot that's making requests to my app. And it contains authorities, which is a way to represent permissions. So in our case with users, the authorities are roles. But if you're using auth, they're going to be scopes. If you have your rich authorization model, you can have complex objects for the permissions. And all of this is stored in the security context. As a user, you can use that. You can use it and print stuff. So let's say add a mapping here. We had an auth endpoint, public, and maybe this one we just return like a simple string, not a template. So string, show auth, right? And so if I want to access the authentication, so the identity of the user, I pass the authentication here. And I can print it, return authentication to string. So Spring resolves the parameter for me and shows me what type of authentication this is. So in here, go here, auth, here we go. So this, I'm logged in with a username and a password. So it's a username password authentication token. It contains a principal, which is a demo user here, and it contains granted authorities. So the authorities, the roles. That is this very, very simple interface authentication here, right? So we have granted authorities, it's a collection, and we have the principal, which is an object, which you know, this is because Spring Security is kind of not the pinnacle of, you know, OO design, but it means you can put anything you want in the authentication principle and the idea of the user. So I inject it like this, but the way this is injected actually is that Spring Security, when you log in, it puts that authentication in something called the security context. The security context is available throughout the app through security context holder get context, static method. That static method returns a thread local. So it returns something that is available in the thread that is executing the request. If I have a second request at the same time, they have different security contexts. And so this here is strictly equivalent to doing security context holder, get context, get authentication, var authentication, right? Oops, var authentication, same name. So if I do this, I will see the same thing. And so this is also what allows the annotations to work, right? Spring Security will intercept the calls to that method and then check the security context, extract the authentication, and then compare the roles to whatever has a role I have in here. Okay? So when I log in, I get a username password authentication token that contains my user and contains those permissions. So we can do fun stuff with it now. Spring Security provides a lot of tooling for authorization. And you can authorize things at 3 levels. So you can authorize HTTP requests, you can authorize methods, but you can also authorize specific objects. And we'll see those one by one, and we'll see the details of what you can do. So first at the request level, let's go back to our application here, and then zoom out a little bit. Perfect. So we had the admin page. Now we say, there's a profile page. So here I'm accessing profile Daniel, and I'm accessing it both with Daniel's account and Josh's account. But I want to change this. I want users to be able to see their own profiles, but not someone else's profile. So how do we do this? Well, all the request level authorizations, they have the same shape. All of these are authorization decision. So this is an authorization, auth Z for short, decision. But this is an authorization decision as well, right? We're also saying, well, if you want to access any page, you must be at least authenticated, right? And this is also an authorization decision. We're saying these pages are open to anyone. So they all do like auth Z.request matcher. This any request is actually calling request matcher as well, but with a special matcher. And so let's say users can only see their own profile page. So we do auth Z.request matchers, and so the profile page is profile/username, right? And so they're all followed by dot something. So dot has role we've seen, authenticated, permit all. We have has authority, for example, right? So here we could write the roles kind of like this. This is more or less equivalent to has role. And there's also one here that's called has variable. So I can check any variable in the URL. Here's username. And then it must be equal to something that depends on the identity of the logged in user, so on the authentication. So we have a lambda here. We take the authentication. Let's write authentication, spell it out, equal to authentication, not authorization, authentication. Authentication, and in here we can get the principal to get idea. We can also just get the name of the authentication, which in this case is the name of the principal. And then IntelliJ tells me use a lambda here. So in here, I take the variable called username and I compare it to the name of the user. So it does kind of what you expect here, right? So Daniel can see his profile, Josh cannot see Daniel's profile, and the other way around, right? If I go to Josh, then I'm not allowed to see Josh's profile. So that's something about data that is in the request path. But maybe sometimes it's not in the request path. So we have this corp endpoint, and we want users to be part of have an email domain that is on corp.example.com to be able to see this page. So Josh and Daniel, they are on @example.com, so they should not be able to see this. So again, we're going to make an authorization decision, and so they have the same shape. So can only @corp.example.com users can access, right? So again, auth Z, request matchers. So I'm using strings for this demo here, but you can also match on methods, saying only the post requests do this. And you can write your own request matcher as well, which is anything on the HTTP request itself, right? You could match on headers or whatever you want. But for demos here, we'll use the path. So the corp path here, and then here there's nothing about email, because email is what I'm paid for. It's my business logic. So Spring Security doesn't know anything about this. So it has an escape hatch, a method that knows everything there is to know. It's called access. So access here takes a thing called a authorization manager of request authorization context. It's a bit scary, but it's just a lambda that has an authentication supplier, right? And then a request context. I'm going to spell them out for the first example. Authentication supplier, and then request context, right? And this must return a new authorization decision, and this takes a Boolean. So are you allowed to see this or not, true or false? So the authentication supplier is the way to obtain the authentication. The reason why it's a supplier and not a hard-coded authentication is because maybe your authentication is kind of complicated, it's in a database, and maybe you don't want to load it every time. So sometimes you don't need it. And so in that case, you don't need to call get, and so it's slightly cheaper. So we obtain the authentication here. And then the request context has the URL, the path, and so on. And so from that authentication, we say if the authentication.getPrincipal is an instance of demo user. So that's my domain class for representing users, and the user.getEmail.domain equals corp.example.com, right? So in that case, if it's really a demo user and the domain is correct, return a new authorization decision of true. And then otherwise, return false. So in that case, I'm checking something about the identity in the principal. And so now, Daniel cannot access, Josh cannot access, but if I access through Alice, who has the correct domain, so Alice is corp.example.com, now Alice can access corp. Right? So I can do anything I want to authorize my requests based on the authentication. And in fact, all of Spring Security request level authorization is implemented with this. So when you go, say, to authenticate it here, it calls access. If you go to has role, this one, it calls access. So it wraps some stuff, but it calls access. If you call permit all, again, access. So all of this is access. So for example, this equal to here is an access. You could write your own. It's completely possible to rewrite this little bit of Spring Security. So if we say this is access, I'm going to make it a class, a new authorization manager. And so what is this? So we have the request context. We have the authentication supplier. And so we can say, okay, the authentication supplier I get, and this gives me the authentication, fine. And then the request context, I get the variables. I get the variable called username, right? And then that's my username from request. And then I return is the username from request equals to the authentication.getName, right? Return a Boolean. Oh, it's an authorization decision. New authorization decision. Come on. No application, decision. Here we go. Right? So this is functionally equals to what I have in Spring Security. So I can check that, see if I've messed up anything. Come here. So Daniel can see his profile, and then Josh cannot see the profile here. And so this, you can make your own classes, and you can even like extract to, like, I want this one, inner class. Named inner class. So this one maybe name matches URL variable, right? And so maybe I make this one and I extract that username as a field. Cool. Initialize in the constructor. Here we go. And then I make that a parameter. Sure. This.username equals username. And so now I write my own little happy name matches URL variable username. It's exactly the same. So same behavior, right? So Daniel can see, Josh cannot see. Why is this interesting? It's because if I want to make more complex rules and I want to compose them, then I have to be a little bit smart. So if I say users can see their page and admins can see everyone's profile. So if I want to do this as well, naively, I could try and do this, right? So if I try and access blah, 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 the profile username, I could say has role admin. That does not work. This doesn't work. Because Spring Security will check your authorization request matchers, will find anyone that works, and then apply this one. And so this will never be applied because this one swallows all authorization decisions. So I could try and go back to this and make an auth supplier and then make a request context, make my own Lambda, and then start making compose stuff. But that's a bit it would be a lot of duplication and creating many classes. Instead, Spring Security has some helpers for you to do this. So, for example, you can do authorization managers with an S, and in here we have Boolean logic. So any auth, which is an or, all auth, which is an and not. So we can say any of these authorization managers will grant access. So the name, and then we want to do this has role, so we can do it, and we have a authorization manager from Spring Security, and we can say has role admin, right? This. So, oh, that's kind of ugly. Here we go. Right, format this. Beautiful. All right. So with this, you can apply any composition of rules. It's much simpler than making your own managers every time. And so now Daniel can see Daniel's page. Josh can see Daniel's page, but Daniel cannot see, say, Bob's profile, because Daniel's not an admin, so Daniel is not allowed to see a profile other than his own. All right. So to recap a little bit what we've seen, request level authorization, it happens in the security configuration in http.authorize HTTP requests. You pass a lambda to it, right? And then we have some rules for you, so very simple ones: permit or denial, authenticated. We have like remember me and fully authenticated if you want to do stuff that to be sure that the user has typed their password recently. And then has role, has authority, and so on. But the interesting bit is when you want more complex rules, and then in that case, you would be using access. The access takes an authentication supplier, a request context, and then you can compose them with authorization manager, right? The thing that this does not do is read the body of the request. So we can do anything on the request itself, on the HTTP headers, the request path, the context, but we don't do the body of the request. In our examples in here, I don't think we've seen something that uses that request context much. So we can do an example. I think I have an example here, right? Yeah, localhost. So this page, say I want this page to be accessible only from localhost and not 127.0.0.1. So if I go to 127.0.0.1, Daniel PW, and then I try and access localhost, I want this to be rejected. So to implement this, it's the same thing, right? So it's access, but this time we don't care about the authentication. So only, can be accessed through localhost only. So again, auth request matchers /localhost, and then access. And so in that case, we don't care about the authentication. We only care about the request context, and we return a new authorization decision, and it's based on the request context. So they get the request, get the server name, and then equals localhost. So if I access through localhost, this is fine. If I access through 127.0.0.1, that's forbidden, right? So from here, this is 127.0.0.1, compile. So this one gets rejected, but if I access from localhost, so close this one. So localhost, this is fine. And in fact, if I access localhost, the localhost path here from localhost, I don't even need to check that the user is logged in. So I'm not logged in here, I can let you in. That shows that authorization does not necessarily correlate 100% to authentication. Think of it as an airport, right? Are you allowed to go to the baggage claim? We don't really care who you are. We only care where you came from, right? If you get off the plane, then you're in the secure part of the airport. So your identity has been checked already. We don't care who you are. We know that you are allowed to go to the baggage claim. So you can make decisions based on the context, not based on the user as well. And so as we said here, you can do anything on the HTTP request, but we don't read the body of the request. That's because the servlet request, this one, right? to read the body of the request, you get an input stream. And so when you read from the stream, you're going to exhaust it. And so Spring will try to read from the input stream again, and then it will fail because you have exhausted the stream already. And so that is in competition with Spring. You can make it work, you can make wrappers and stuff, but it's clumsy and we don't want you to be doing that. So anything that doesn't read the body of the request, you can probably do with HTTP request level authorization. For the rest, if you want to access the body of the request, this is where method level authentication is interesting. Authorization, sorry, not authentication. Before we get into method level authorization, do you have any questions? Mm-hmm. So the question here is that we have different groups of rules and then group them together. And we would like to use several filter chains or several authorization managers. So this, my friend, this is correct. This is a great question, but it will come later. We will discuss this. I am sorry you are stuck with me for another hour and a half, but we'll discuss that. Any other question? All right. So far, so good. Only one person is sleeping. I will tap on their shoulder when we get to the break. So method level authorization. Let's do a demo instead. Let's do the demo first. So we have our shipments, and they're here in this page. I can see the shipments. Beautiful. Now I would like to secure this page with, again, an email domain. And I don't want, for some reasons, I don't want to do it at the request level. This should really be at the request level because all the information is already here. But imagine we want to do it at the method level. So again, we have enabled method security in our security configuration in here. Right? So we can go to we can find the controller, demo controller. We have a shipments here, which calls find all on the shipment repository. So in here, we can add pre-authorize. And so we're saying in here, we want users with corp.example.com to access this page and not the others. So again, there's no has email here, right? Email is my own domain concept, so Spring Security doesn't know anything about this. Has role, yes. Authenticated, yes, right? Fully authenticated and so on. Security level stuff, yes. Your domain, we don't know about this. But we give you access to the authentication object. So the thing that is in the security context is available here. So we can get the principal from here. So principal, right? And let's say get principal, sure. And then this one is a demo user, so it has a get user email, and it has a domain, and we can say equals, we said this would be corp.example.com, right? So compile this, and I go to here, and so I get HTTP 403, authorization denied, because I am not corp@example.com, right? But Alice should be able to access this. Go to private, Alice, PW, and then shipments, and Alice can see that. So I can check her email in here. So this is a Spring expression, language expression. So you can do lots of stuff in here based on strings. This dates back from the years of XML. And with this, we can make requests, decisions, that are more complicated than that. So for example, I have re-implemented the security, the profile page. So I can access the profile through method security profile Josh. And so let's say we want to secure that method that gives the profile. So again, that's the controller method security profile. I'm going to use here this is load by username. This is used internally by Spring Security, so I don't want to override that method. So our user details service here is a demo user details service. And it's provided as a bean, so I'm going to specify that bean a little bit more here. Demo user details service. Here we go. So it's a user detail service, so it works the same, but now I have access to more methods in here. So in here we have load by username. So this is used internally by Spring Security. I would probably leave it alone. Otherwise, you're going to have problems. So instead, I re-implemented find user, just so we have a demo. So we use find user here. And so we can write authorization rules on this find user method. And so now we say users can see, say, the same domain. So if I am on the same domain as a user, I can see their profile. So users can see other users with the same email domain. So, you know, with what we've seen, I would do like at pre-authorize, and then maybe I say, well, authentication get principal. We know that you do a lot of stuff about the identity of the user, so we have a shortcut for this called principal. You can access the principal directly. JetBrains knows this. This comes from Spring Security. And so get user email. So that's the logged in user, the principal here. And then it has a domain. And we want this to be equals to something. We want the domain of the logged in user to match the domain of the other user. But before we call this method, we don't have the other user. We have the username. But maybe that username doesn't even exist, right? Maybe someone is trying to access profile, blah, 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 Josh, and then maybe in here, I don't know, they do Carol, right? And I have no Carol in my system, so I can't compare Carol's email domain because it doesn't even exist. So this decision I cannot take before I execute the method. So I cannot pre-authorize. Instead, I post-authorize after calling the method. Then in here, I have access to the return object. Return object. So the return object is this one. That's a Spring expression language construct that gives me the return value of that function. So in here, this return object has a get user email, which has a domain, right? And so if my domain is the same as the domain of the return user, then I let this through, right? So now I can see Josh's page, but I cannot see Alice's page because Alice is on a different domain. And in all these methods, pre-authorize, post-authorize, you can do stuff that access, so the return object is one thing. Let's do a text block here. You can also access the arguments. So here we have the username, and maybe we say when the username is Bob, then anyone can see their profile. Poor Bob. So I have a different domain from Bob, but now anyone can see Bob's profile in here. Technically, this is a pre-authorize. I can make the decision before. But I can write any complicated logic in here, which goes really bad. Then I come to your company, I see your code base, and you have 25 lines of Spring expression language, and this is horrible. Instead, when you start having complicated, more and more complex use cases in here, since this is the Spring expression language, you can delegate to a bean. So you can put these rules into a bean. So in here, let's do that. Call it authorization service. Cool, it's a service. Make it public just in case. And then we're returning booleans from this and has same domain. And so this takes a demo user, logged in user, demo user other, right? And we'll return logged in user, get user email, domain equals other, get user email, domain, right? And so now, so this is a very simple, where is it? Authorizations for it. This is a very simple Boolean expression that I write in Java, not in a string. So this is compiled, this is checked at compile time. And now in my service in here, I can call to that bean. I can do authorization service that has same domain between the principal and the return object. Right? Compile this. So again, so I can't see Bob's profile because Bob is in a different domain, right? But I can see Daniel's profile, right? And I can see Josh's profile. We're in the same domain. And there's something really great about using a bean here. Does anybody have any idea what's great about this? Yes! Beautiful. You get 1 brownie point. That's beautiful. Look, my unit tests. Nerd. My mom is very, very proud of me. So here you can write your tests, right? You can make a private, final authorization service, new authorization service, and then you make a new test method, and it's called, has same domain, right? We create a new demo user, ignored, the name is ignored, and this second is the password, ignored. And then the email, daniel@example.com, and then list, empty list, no roles, right? So that's Daniel, right? And then we can make Josh, and we assert that, import static method, this one from assert.j. So assert that service dot has same domain between Daniel and Josh is true. Right? And then you can run this test. And it takes milliseconds, 37 milliseconds. If I turn this into a Spring Boot test, look how slow this gets. No, terrible, terrible, right? So very cool. You can also write the opposite tests. So it has different domain. And so now we take Daniel and we say Alice. Alice, we put her at corp.example.com. Alice, and so is false. That's beautiful, right? Now it goes fast, right? And then you can also write more tests. There are bugs in my code, right? Take this, and compare Daniel to null when the user doesn't exist. And then that's not great, right? So I can go, I can fix it. If other equals null, return false. Right? And so I can test that. Much better than trying to write your own complicated logic for testing, or like your full stack tests that make HTTP requests to test maybe a complicated auth domain. Now you have a bean, you have unit tests, and you are happy. One word on this shipment repository here. So in the demo user detail service, we have done a post authorize in here. This works for a single item. If I have multiple items, if I do post authorize, it does the authorization for everything. Maybe I want to filter. So when I return a collection, there's another annotation that exists that is called post filter. So this one filters the objects from the return value here if they're a collection. So in here we can say filter object dot ID modulo 2 equals 0. Right? It's very, very good business logic. So now I think only Alice can see the shipments. Localhost, Alice, PW, shipments, right? So I filter and I authorize and I say, oh, this object, yes, this object, no, this object, yes, this object, no. One caveat to this, this is security, not your domain, right? So in here, you don't want to be loading 500 megs of object in memory to filter them before returning them, right? In here, you probably don't do this. Right? Instead, you want to do something like select star from shipments where ID modulo 2 equals 0 or something, right? Equals 0, something like that. Or a real security exception, right? Select security user checking, right? Select star from shipments s union like join left join users u on s.user id equals u.id, etc., etc., right? You do want to do that in your domain. Don't do it, please, in security. If you do it in your domain, you can add a layer of security on top of it. This is fine. But when you can, so if you're calling a service and that microservice doesn't have, like an HTTP API, and the HTTP API doesn't have a filter function, then maybe you can use post filter. But this is something you do on top of what already exists, right? Please don't filter your domain with security expressions. The last thing I want to show with this, or two last things, is the composability. So here we say the shipments, only corp.example.com can see the shipments. But what if I replace this with a text block? And what if I say, there's another domain that's allowed, right? And that domain this time is just example.com. And so maybe I have variations in my app. Sometimes it's corp, sometimes it's both, sometimes it's all domains, and so on. It would be really nice to, instead of doing that, it would be really nice to do add allowed domains, something like that, domains equals, and then example.com is allowed, and then corp.example.com is also allowed. So create this annotation, that is possible. It's for methods for now, method, right? Retention is runtime, beautiful. And here we can put our pre-authorize. So now we're making a meta annotation of pre-authorize. And we want some domains. So string domains, here we go, function. So in here we say, well, let's put it in the authorization service, allowed domains, and we take the principal, right? And then we're going to check some domains. So let's implement this method first. Allow domains, come on, authorization service, public, boolean, allowed domains. So it has a demo user, logged in user. It has string, array of domains, right? And so we'll return arrays as list of that domains contains logged in user, get user email, get domain. Here we go. So we need to pass these domains from the annotation in here. And so to do that in Spring Security, you can template this value in that string up there by doing domains here with quotes, and then you put curly braces. If you want to find this out, right, you go to Josh's third favorite place on the internet. Do you know what this is? So the first one, what's the first one? Production, yes. What's the second one? Start, the spring.io. But you know what the third one that he never talks about? Docs, the spring.io, of course. And I'm pretty sure his favorite is probably Spring Security Docs. They're amazing. So in here, right, you can go to the whatever stack you're using here, servlet. You can go to authorization, and then method security, right? And we have lots of use cases. Oh, I want to have fallbacks. I want to have this. I want to have that. You look for meta annotations. Meta annotation. Here we go. Meta annotation. So it tells you, oh, here's how you can do this. And if you want to template, you have to provide a flag that says, yes, I want to template values in. It's done through the annotation template expression defaults. And you can see the example here. And so we say, put in the security configuration. So we provide that bean, annotation template expression defaults, and then you call it Java. Naming is fun, isn't it? Right, return a new annotation template expression defaults. Okay, build this. And now, close that. And here we go, yep, there we go. Localhost, go to private, Daniel, and now, Daniel can access the shipment page, Alice can access the shipment page, but poor external Bob, who's at ext, is not allowed to access the shipment page. So now, if I have different rules and different methods, then I can reuse this annotation now on my, I don't know, my controller here. Say, oh, this auth page. You say allow domains, and only example.com users are allowed to use this. And you can reuse it across your entire authorization stack. The one point that you want to take into account, though, these annotations are not repeatable. So if you do add pre-authorize in here, IntelliJ will yell at you. It says this is not repeatable. You're not allowed to do this. If you do meta annotations, it's the same, right? This pre-authorize, say has role admin. The pre-authorize is in here in this meta annotation. So this, IntelliJ doesn't see that, so it doesn't complain. But when I try and go to that page, then Spring Security complains, and it tells you, please ensure there is only one unique annotation of type pre-authorized attributed to blah, blah, blah. So you would have to find your own way of composing these meta annotations if you want complex rules in that case. And that's it. One last bit with method security is, I think we've seen it in the docs, docs.spring.io. Where is it? Docs, this one. Spring security reference, there we go. Method security, right? And so in here, we saw fallback, providing fallback values when authorization is denied. Remember our use case of the demo controller that says, I handle authorization denied exceptions in here especially. So we're breaking the separation of concerns. That's not great. We want to avoid this. Instead, what we want is to do this, right? Do that, and then let the authorization domain do its thing and filter what you need to filter before returning. Okay, so one thing you can do is provide a special handler when an authorization denied is raised. So you do handle authorization denied, and and in here you pass the handler. So handler class, let's call it null authorization denied handler class. Cool. Create that class. Cool. It implements method authorization denied handler. It must be a bean. Component, no, component. Here we go. And so when you implement the methods, you have two possible methods. Handle denied invocation. So before I call the method, something is denied, or post authorize, right? So I want to check before or after. So the default is before. So let's do that. Implement the method. This one. So when auth the denied exception is thrown, instead return, and in that case we'll return null, right? So compile this. So now our demo controller doesn't know about the authorization domain. There's no authorization code in here either. It's outside. But when I go to the main page, right, in here, it works the same. And this authorization denied is just replacing the return value by something. So if I replace this with 42, right? So when Daniel calls this authorization denied, and we pretend there are 42 shipments, whereas Josh has the real value in here. He has 4. So instead, in here, we really want to return null. Return null, so Daniel doesn't see the shipments. Okay. Okay, so that pretty much covers method authorization. So we have pre-authorize, post-authorize, post-filter. So when you can do pre-authorize, there's also a pre-filter if you have collections of objects. When your authorization rules are non-trivial, you want to use a bean, an external bean with at authorization service, at blah blah my service. And remember, these annotations are not repeatable. When you use the same rules often, but they have slight variations, you can template stuff by doing your own custom annotation, and you have to turn it on with an annotation template expression default. And lastly, that's a very important bit. Please, when you do post-authorize, post-filter, do not confuse this with filtering your domain. right? This filter in your database, check stuff in your database, don't load too many objects. You can have post-authorize as maybe as a safety net, like defense in depth, if you will. But it's not made for filtering stuff at the output of your method. And again, separation of concerns. You don't want security code inside your business domain. So you can annotate with handle authorization denied here and put all your security code in beans or in custom annotation. So if you do this even like that, your security code is hidden beyond your own layer of abstraction. So if you want to remove Spring Security for some reason, I don't know why, but maybe, then you can change what allow domain represents. Okay, so that was method security. Do we have questions for method security? Nothing. The room is quiet. Oh yes, there's a hand.
When would you rather prefer request or method level? Would you always go for request level first, then minor tuning code method level as the layer, or?
So the question is, when do you prefer request level versus method level security? So we'll discuss this again a little bit later on, but the idea is it's a design choice, if you want. If you in request level, your security rules tend to be all in the same place. So they're far from the code they actually secure, versus method level, they're right next to the code. There's a big conceptual difference, though, is that the request level comes very early. It comes before Spring actually tries to parse the request. So if someone sends you a gig of JSON, with request level security, you're not going to parse it. So you're not going to be wasting resources trying to check what's in there. Or if you have a CV in Jackson, then by doing request level, since you're not touching the body, then you will be more protected than with method level. So method level is, you must use it when you need something about the body of the request. And then the second is, the second choice is, well, I would say prefer request level, but maybe you have a stylistic choice and you have linters in your company that's easier to enforce that every method in a controller is annotated with @pre-authorized, right? And so you can enforce security rules, so you can have choice. And then it's not mutually exclusive. So you can have request level authorization and then a second layer of more fine-grained authorization that looks at the body of the request at the method level. Even if it's redundant, it's allowed, and you can have like HTTP, pre-authorized, post-authorized, all for the same request. This is completely fine. Cool? All right. Yes, another question.
I have a question about the support for in case of method level or request level.
Uh-huh.
Is there now support for OpenID Connect claims or scopes, or I have also to do it manually, like with access?
So the question is, I'm using OpenID Connect to log in. So single sign-on, for example, with Google, and then I get an ID token back. This ID token contains identity information about the user. And the question is there a support for checking that some claims in a JWT, JSON Web Token, or some identity claims about the user mean something in particular? That's the question? Yeah. Claims and scopes. So scopes is when you're doing auth. So an access token comes in, and the access token is linked to scopes. By default, Spring Security, if we secure the request with access tokens, the way you do this is in security configuration here. So you say, I want to secure a request, secure with access token. So it's not about logging in, it's about authorization at a certain level. So in here you do OAuth to resource server. This is the thing that checks the tokens that come in. When you use that, the authentication that you have is a JWT authentication. I don't have a library in here, so we can't see it. The authorities are extracted from the scopes and then put in a special string called, or a special authority. So the roles they're represented, roles are, so if you're admin, that goes into role admin, right? And then scopes, by default, if you have the scope message.read, it goes into scope underscore message.read. So that means you can do auth_z.requestMatchers. I don't know, foo, and then has authority, not role, and then you do scope bar, right? So you can do that with scopes. This is supported. If you're doing OpenID Connect, so OpenID Connect is for logging in. So if you do OAuth to log in here, and you use an OpenID Connect provider, then you get an OIDC user, and it has claims. And so for that, there's no direct support. You would have to do access, and you inspect the authentication. But you can also, if your claims translate to something, you know, if you say have a claim called group, for example, and these groups, they represent roles, you can have a mapper, an authorities mapper, so something that you inject in your OIDC configuration here that will take the claims and then produce authorities. And so you can say, oh, well, I get the groups claim, and I extract a list of strings, and I transform these two roles, and I put them in authorities. And then I can do has role here based on the group name. So it's like a head. If you're not doing authorities, because maybe you're saying, oh, these claims that I'm checking, they have different IDs, and I have like many different IDs, or many different claims for different endpoints, and I don't want to have like 5,000 authorities, then you would do it at the access level here. Cool? All right, we'll get into this a little bit later with thinking about authorization and so on. How's everyone? Are you still, who's sleeping? And one person sleeping, great. Okay, one more thing before we take a break, because it's going to be an hour and 15 or something like that. So object level authorization. This is rather new. Who knows about object level authorization in Spring Security? Exactly, one person? Yeah, okay. Well, so this is new. This came out last year, I think November in the 6.4, maybe 6.3, maybe it was May, I don't remember. And so the idea here is we have our beautiful shipments that everyone with example.com or corp.example.com email address, they can access, right? But maybe in that shipment, there's an address, and we consider that address as PII, is personally identifiable information. So it's something that not everyone should be allowed to see. Credit card numbers, for example. And so I want only admins to be able to see this. So you can't really do that with a security annotation. You could cheat with post filter, like a post filter could map objects and so on. You could write your own AOP stuff that is not like your own annotations that are not Spring Security specific. But it's been a year that you've been able to take the shipment object here, and you find the address. Here's the get address here. And now you can annotate the getter methods in here with pre-authorize. That's allowed. Has role admin. If I do this, this is a plain Java object. So this is a very simple data container. So this will not work because Spring Security will not pick this up. So if I go here, like I think I've compiled, yes, I have. So right, it still works the same. You have to tell Spring Security that you want to take your objects and you want to inspect annotations on getter methods or on any method on that object. And so in that case, you have to find the call sites. So what returns those shipments? So in our case, it's the shipment repository. We have this find all here. Okay. And so in here, you would do authorize return objects. And so by doing this, Spring Security will wrap every shipment here in a proxy that will check authorization every time you call a method. So is there a pre-authorized, is there a post-authorized, and so on. And so in that case, yes, we check the authorization on the shipments. So Josh is admin, Josh is fine, but Daniel is not admin, so authorization denied exception, and we got an HTTP 403. That's not great, right? We don't want this kind of ugly page. I just want to remove the error on the address on the shipment. So in here again, we can use the handle authorization denied annotation. We create a new handler class, and we call it what? Redacted authorization, redacted auth the denied handler dot class. Cool. And so create this. Sure, this is a component. We implement the methods, and then when the user is not authorized, so when auth the denied, no access, instead we return a string that says redacted, right? Or like *** if you want, right? And so in here, compile this. Josh, nothing changes because Josh is admin. Josh is allowed to see the shipments, but Daniel, when the serializer kicks in and then reads the get address, then an authorization denied exception is thrown. The handler class captures it and then replaces it with the value I want. And so this is very simple. This is just a hard-coded thing, but in here, you have access to the method invocation and to the authorization result. So the authorization result is just a Boolean, granted or not, but this is an interface you can implement. So if you have complex authorization and you want to explain why the authorization was denied, then say your pre-authorized annotation could return an authorization result that is rich, that has, oh, it's because Daniel is not admin and I want to show it, right? Okay, so the trade-off with this, though, is that you're going to wrap every object that returns from that method into a Spring proxy. So you're going to have one layer of indirection, and it's going to be expensive. So if you have, if you do 5 million shipments a second, then maybe this authorization model is not great, and you should be optimizing for performance a little bit. If you have the internal CRUD application that has exactly 5 concurrent users from 9 a.m. to 5 p.m., then this is perfectly fine. You can do that. You can wrap with authorized return object. It has tooling that you can configure. We won't go into the details, but it's the shipment repository. I did authorized return object here on the method level. I can also put it on the class. And I can put it on the class in here at authorized return object. If I do this, it will proxy every method. So then I'm going to start proxying integers, and that's not great. So there's stuff you can do to decide what type of proxying you want to do. Again, you go to the reference documentation, you go to authorization, method level authorization, because we're authorizing methods here on objects, and you'll find all the options you have. All right, any question with this? Yes?
So would you be able to show the address if it is my shipment?
So the question is, would you be able to show the address if it was your shipment? Absolutely, absolutely. So in here, we have shipments, and our shipments, they're very simple. They have address, status, and so on. And then we could have a private final string. No, let's put an email. User email, right? Import, sure, add to the constructor, right? So this is an internal, maybe we don't make it accessible, it's fine. And so in the shipment repository, we have 4 shipments. So let's take all these new shipments here, boop, boop, boop. Actually, you know what? When I did constructor, let's go to the shipment. I think IntelliJ can do that for me. Do this, right? And then we change the signature. Is it F6? Change signature. Here we go, Command F6. So I can add a email, user email, and the default value is new email, daniel@example.com, refactor. Okay, that's great. So now IntelliJ has done all the migration for me. Beautiful. It's not very readable, but let's say the first shipment is Daniel, let's say the second shipment is Josh, and the third is Alice and Bob. Sure, right? They each have their own shipment. So now in the shipment here, I can say authorize here, pre-authorize. I would probably put it in a bean, and oh, I'm not sure I have access to the this object. So I go to my favorite place. Go here, method handler, method security. Okay, and then spell access this. Actually, you know what? Access this object. I'm pretty sure it's possible, but I've never done it. This, hashtag this, perfect. So this dot get or this dot email, user email, and then I need the authentication. So principal get user email domain, not domain, equals this dot user email, right? Okay, and so I'm just going to be sure that there's an equality check in the email. So no equals sure. Cool. All right. Do you think it works? I have no idea. So it doesn't work. Template exception. Oh, because the email is this not. Okay, let's debug this during the break. And then I'll come back to you. Probably. Oh, user email is not public. Okay, fine. Sure. All right, so let's make a getter then. I lied. Getter for email, and then this get user email. Okay, try that. Okay, new thing. Truck. Okay, if it doesn't work this time, then I'll stop. Failed to evaluate this. Why? Get user email cannot be found on type expression. Oh, this is the expression root. Okay, debug during the break for now. But that's a great question. Thank you. Anything else? Can I get a coffee? Yes, you can. Excellent question. See you in 15 minutes, something like that, at 3:05. Yeah? All right, see you in a bit. Wow, you came back. So who's the great question person? You're here, right? Yes? Okay, I have something for you. This. Look at that. One keystroke and I fix it. Boop. And then this. So compile this, and now look at this, right? So I see my address, and then I was like, I'm going to ask Claude, but then I figured it out, right? So Josh can see shipment number 2. So the way you access these things is to evaluate this. There's a thing called the expression root in our Spring security. It's called the security expression root. And so this thing gives you methods that you can use in here. So remember when we did, say, I don't remember the repository here, has role. If you command click in here, it will bring you to the security expression root. And so this is what captures the authentication object. This is what gives you the principal. Get principal translates into principal, and then permissions, and then expressions, and so on. And so there are this is an abstract class, and there are 2 implementations of this. There's the method security and the web security. So web is for the old spell expression in access methods. The method security expression root So this is now you would use this, the web one, you would use that with XML. The method one is the security expression root that is available in that magic, shipment, that magic string in here. And so method security expression root has get this. So you can do this, and it will basically get this, and then this is where you get the return object and the filter object when you have post filter. They come from this part here, right? So it works. Thank you. I learned something. See, I come here to learn stuff. Usually I don't do it in front of the camera, but see, I learn stuff all the time. All right. Do we have any questions before we get further along? Yes, questions. No, not sorry. I am asking for questions. I am asking for this. Yes. So is there integration in Spring Data to do integration between Spring Security and Spring Data and do stuff at the database layer to avoid this authorized return object, which is expensive proxying? And the answer is no. Because multiple things. The first one is that they're very different domains. And Spring Data is a very rich project with many, many integrations. And so we have to think about so many things in security that I think it would consume all of our time. So we love the data folks, and the data folks love us, but we all stay in our own houses because there's only so few of us. But community projects, right? If you want to learn this stuff and you have a specific use case, that's a great way to discover that. I discovered tons of stuff by doing silly projects that I need for myself. So, do it, try it. If it's cool, if you like it, promote it, and then maybe we'll see you here next year showing us, and I'll be in the audience asking nasty questions. All right, anything else? Cool, let's get cranking. So, now, before we get into the hard part of the topic was the authorization design and how you do stuff in some patterns. I want to talk about the internals of how this all works. So I had a very good question. I was very happy with this question during the break. Someone came to me and said, well, you're saying in your security configuration, and you say, I don't know, any request authenticated, or you're saying, oh, the admin page, you must be admin, right? And so when I access it with someone who's not admin, localhost, and then Alice, Daniel is not admin, so we could use that admin, right? So I get a 403, HTTP 403, because this is not, the condition is not fulfilled. Daniel is not admin, he cannot see the page. But if I try to access it from the outside in here, and I try and type admin, right? If I do this, I get redirected to the login page. So what I'm getting in here, this thing, let's do F12, we show the network, and then I try and go to admin, right? I get HTTP 302 redirected that says, blah, blah, blah. You must go, so this is a redirection, so you must go to the location, localhost 8080, login to here. So it's a different error in here. It's not a 403. So I expect a 403. I gave a rule, the rule is not fulfilled. Why am I going here? And I said to that person, excellent question. We're going to talk about this right after the break. So, before I can explain this, I have to explain how Spring Security works, at least in servlet mode. What we're doing here is mostly servlet. In reactive, it's not HTTP servlet request, it's a web request. It's slightly different, but the general concept applies. In servlet mode, Spring Security works with a security filter chain. So we've seen, right, when we build our security rules here, we return a security filter chain. A security filter chain is just a filter chain, which is a chain of filters, so a list of filters that are applied in order. The filter chain is not a concept from Spring Security. It's a concept from the servlet spec. So this is in your servlet engine, in your Tomcat. When you make a request, Tomcat is going to execute some filters in order, and then at the end, it will go and execute the servlet, the thing that contains your business logic. In the Spring world, this will then be dispatched to your controller method. So when you think about it, at the bottom of your filter chain are your controller methods that return values, maybe also your static files. Spring Security has a special thing inside the global filter chain for the servlet container, which is the security filter chain. And we put all these security filters within that one chain, so you can see all the security decisions that are taken. And so when a request comes in, at some point we hit the security filter chain, so we execute filter number 1, then filter number 2, 3, and so on. Then we get to your business logic. And so once this is done, we're getting out of the filters in reverse order. So the reason this is happening is because it's a chain of responsibility pattern. The way we implement this, each filter has a do filter method, takes an object that is the HTTP request, it takes the response, and it takes the filter chain in which it lives. So before going further, it's going to look at the request and decide whether it should be applied or not. Because maybe, you know, when I do a login, I'm posting to login, and so only then do I want to check the username and a password. So we do it here. Sometimes we even write to the response, and we say, ooh, password is wrong, reject. We don't do the rest. So we would stop here at the login phase here, and then reject. If that filter is okay with the request, it says it invokes the chain and invokes do filter on the chain, and the chain is going to find the next filter, and so on. So the way this is done in pseudocode, a request comes in, we instantiate, this green thing is the filter chain instance. So a request comes in, we increment the position, so we get filter at position 1. So we get that filter, and then we call do filter on it. So it goes here, it goes into the filter. We do the before step, right? And then we call back into the parent, and now we're in the second step, so 2, right? We increment. Now the filter is at position 2, so we get the second filter, then we call this one, and then this one calls back into the parent, and so on, right? And so the stack trace, if you will, is kind of like this, right? I have the filter chain, it calls filter number 1, filter number 1 does its thing, it calls back into the filter chain, it calls filter number 2, 3, 4, and when we're done, we go out in reverse order. So if a filter is something like this, let's do plain text, that's beautiful, right? So remember, it has a do filter method, takes a request, response, and a chain, right? And it has before, like check security, if you will. And then it calls chain, do filter, request, response, right? And then after, usually some cleanup. So when you implement your own filters, you usually don't have to do an after bit. This is for us. This is for the framework. You can, it's fine, but usually we use it for that. So that means when the request comes in, down, right, request comes in, and then we're going to call into filter 1, and then filter 2, filter 3, and so on, right, dot, dot, dot. Then filter n, right? Then we call the Spring dispatcher servlet, which will call your add controller methods, right? This one returns, and so after that, the filter 1 we've called here, it's done the before step. So it does the before, 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 before. And then once we're done, then we get out of the filter, filter n, and then we do the after step. So filter n minus 1, we do after, dot, 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 and then filter 1, we do the after. So this is how this is executed. So this bit after here. If you want to find out the filters in your filter chain, and really, if there's one thing that you need to remember from this presentation. The one magic trick. You go to your application YAML or application properties here, right? Wake up and remember this. So, I have a problem with Spring Security. I want to debug it. I want to find stuff about it. I do logging, level, IntelliJ, logging level, org.springframework.security, trace. And then, oh, this is YAML. And then I do ta-da. You are now a security ninja. Beautiful. Yes, this one. Ninja. Voila. Your team will love you. But the problem is they will come to you to help them debug their filter chains and their security problems. So I don't know, maybe it's a curse. So when you do this, you get some debug and trace level logs, and you get a log from default security filter chain that tells you, I will secure any request with the filters. Disable encode URL filter, web async manager, integration filter, security context filter, blah, 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 and so on. And then all the way to the bottom, exception translation filter and authorization filter. If you've seen my other presentation about authentication, when you make your own filters, you usually put them before authorization filter. So this is, you put them here, right here. This is a good, safe place because authorization filter is the filter that does authorize HTTP requests. Security configuration is that thing. So if you need to know stuff about the user, you need to detect the user first, so you be sure you do your own filters here. When we do a request, before doing a request maybe, so we had these filters. Let's actually restart the app. I want to see that again, right? So here we go. So we have our filters here. And these filters are added as I add features into Spring Security. So for example, here, there's a username password authentication filter. There's a default login page filter and so on, right? So if I go in here and I remove form login and I build again, and then my app restarts, you'll see this log is slightly smaller. We don't have the username password authentication filter anymore. We don't have the default login page filter anymore, so we have less filters in that case. So all of these things, these configures, there are configurers in here, they add filters that will act on the request. Okay, so this is the the static part of the application. So I have some filters, they're loaded into the filter chain. And if I want to see them in action, then I'm going to clean this, and then I'm going to make an HTTP request. And I'm going to make this HTTP request fail, right? So if I make a simple HTTP request to private like this, I get redirected to login because I'm not logged in. So it's a HTTP 302 found, and the location is blah, 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 8080 login. Fine. But, clean that. If I do HTTP blah, 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 to private, but I post instead, or even to foobar, right? This is going to fail, but it fails differently. HTTP 403, forbidden. Not the login thing, right? Not redirect to login. Does anybody have any idea why? Right, neither do I, usually. So that's why when I'm developing stuff, I put these traces, and then I can come here, right? I go to the very top, so I have a lot of trace and debug logs, and it tells me securing post to foobar, okay? Invoke and disable encode URL filter, 1 out of 15, so I have 15 filters that will be encoded, blah, blah, blah. Invoking CSRF filter, 5 of 15, and then responding with 403, right? We did not find a CSRF cross-site request forgery token. So this post request is rejected. Who's been bitten by CSRF before? Right? Yes, 30% of the room, right? And so with this, you can see we stop there, and then we secure the error page, which is fine. The error we do get the error, but 403, right? So with this, I can debug my filter chain. I can see what's happening bit by bit, and it's extremely useful. It is very verbose. You don't want this in your production, but for debugging something, so for developing, it's great. And If in your production you don't understand what's happening, you add the envar, right? Logging level, org, spring, framework, security equals trace. And then with that, boom, start your application in prod, and then you get the trace logs, and then you fix all your problems, and then you send me an email and say, yo, Daniel, you saved my day. Yes, I'm happy. Okay, so we have our filters here. And we've seen that at the bottom, there's an exception translation filter and an authorization filter. So the authorization filter is the thing that authorizes HTTP requests. So when a request comes in, and we have security configuration, and we have some rules in here, they're configured in the authorization filter. Authorization filter. So the authorization filter has a do filter thing. And so in here, it does authorization manager, and it says, okay, I am going to authorize the request and decide, is this allowed or not? It's going to publish an event. And then if there's no authorization, so if it cannot decide about this request, or if it has decided that the request is not granted, then it throws an access denied exception. If the authorization is granted, it says carry on, right? So we'll put a breakpoint here in the authorization denied. So the normal case in here is authorization is allowed, and then the authorization filter is basically a no-op. It's going to say, I check this, and then call the rest of the filter chain. The exception translation filter itself, there's already a breakpoint here. It calls chain do filter, and that's it. That is the only thing it does on the normal path, and then catches exceptions. So IO exceptions, that's an IO exception. We don't do anything about it. But for a normal exception, for a exception, we check, is this a Spring security exception? So is this an authentication exception or an access denied exception? And if that's the case, then we are going to handle it. So I'm going to put a breakpoint here as well. So if we do a request to, say, private, not a post here, so private here, we're not authorized. Debug. Here we go. Great demo, Daniel. First try. Amazing. There you go. Wow. So we're not authorized here. Right? We've checked and we've said, okay, this request, you must be authorized. You are not, because you're not admin. Then authorization denied event in here. So we authorization denied exception here. We throw the exception, and then it's caught by the exception translation filter because it was thrown in this block, because it's the filter after me. And so we handle this exception. If it's an authentication exception, so for example, if the password is wrong or something, we do something special. If it's an access denied exception, so for example, authorization denied, then in here, we check stuff. So we do some logic in here. And this says, are you logged in or not? Depending on if you're logged in or not, it will do different things. This is here. This is where this happens. So in here, so if the authorization filter says you're not authorized, it throws an access denied exception, and then the exception translation filter decides what to do and which response code to send you and what what headers or what redirect it must send you. So if you are authenticated and we have an access denied exception, it's because we know who you are and we know you don't have access to this. So 403. But by default, if you're not authenticated and you have capabilities for logging in with a form, for example, we say, well, we don't really know who you are. So we don't know for a fact that you don't have access to this. If you log in, we will know who you are and we will be able to make this decision. So we redirect you to HTTP 302/login, right? So 302 found, location is login, and then you log in, and then we can do that dance again and check your authentication. If you're doing HTTP basic, we do 401 plus a header authenticate that decides, that brings a dialog in your browser, or like that lets your system know that it must pass credentials. So that's the case when the access denied exception is thrown by the authorization filter. But any access denied exception in the stack after the exception translation filter are handled by the exception translation filter. So if the authorization exception, if the authorization filter says, yep, that request is fine, let it through, but your controller method or your repository method or shipments or whatever throws an access denied. So we've seen authorization denied exception here. This is an access denied exception. This is one instance of access denied exception. So if your add pre-authorized method throws access denied exception, then the authorization filter throws itself the same exception, right? It rethrows. So basically in the authorization filter, right in here, this thing throws. So the exception translation filter catches it and then redirects you or gives you an HTTP 403. And so in here, even if it's your business code, you could throw access denied exception to start a authorization check, or maybe like send a 403 or send a start authentication. So I heavily discourage you to put authorization denied exception in your code. The idea is separation of concerns, authorization is outside, but if this happens, this is what is going to handle it. If you want to configure the exception translation filter, and we'll see an example later on, hopefully, you can do dot exception handling, exe, and then in here you can do a bunch of stuff. So you can decide how the exceptions are handled if you have custom logic. So I don't know who asked the question, but does that answer the question? Yes. Okay. Great. I'm happy. All right. So we did all the technical part, the easy part, where we have just tooling. I gave you an hour and a half of reference doc. You know, I sit in my chair, take my pipe, and then start reading the reference doc to you with some examples. But what you're not finding in the reference doc is the patterns for building your own authorization systems. And there's a lot to say. And I don't have a grand theory for building your authorization system. Usually after these sessions, I know some of you will come to me with like your bizarre company edge cases. Oh yes, internally my users, they present a certificate when they use the company browser. And so we do MTLS login, but they can also log in with a form and they have slightly different permissions. And when the domain is this, and so I can't answer everything here, but I can give you some pointers for thinking about authorization. So the first thing you want to do is think about the problem. Then we'll see a little bit about what information you need to make authorization decision. We'll discuss multiple filter chains. Someone asked about multiple filter chains, so we'll discuss that. And then if we have time, we'll discuss access control models. So what's in the wild, the trade-offs and so on, and how they can integrate with Spring Security. And we'll see. So thinking about authorization, when I prepared this, I went to the internet and I looked up how that works, and I found this XACML thing. Anybody knows what XACML is? Oh yes, one person.
Acronym I don't know, but it's an entire system to handle authorization.
So you don't know what the acronym is, but it's an entire system that handles all your authorization, and it's all written in XML. Exactly. Extended Access Control Markup Language. So as you can imagine, it was the early 2000s. Like you wrote your Spring Framework 1.0 applications using web.xml and spring.xml, and then you wrote all your roles in XML, and it was awesome. We don't do that anymore for some reason. The XACML itself, I don't encourage you to use XACML, but they define very well something that you find in all access control methodologies, if you will. They say when an action happens, when a request is made, when the user clicks a button in their desktop Java app. Somebody works on a desktop Java app here? Whew, I'm sorry. Yes, 1, 2. Yeah, that happens. We have a few entities that we have to consider. We have a few points. They call these points. And they're policy points. So the request comes in, and the first thing we meet is the policy enforcement point. So the policy enforcement point, think of it as it's the cops stopping you when you're crossing the border, for example, or stopping your car. So the cop stops you and decides, he is going to decide, and then is going to either, I don't know, impound your car or let you go. And so that's the enforcement. Let you go, impound your car, the cop stopping you. There's the second point is, where is that decision made? So the first is the request comes in, and then maybe in my app, maybe in a gateway outside of my app, something decides what to do with the request and then acts on it. The decision might not be in the same place. It might be a different point. And this is what decides, can Alice access resource 123? And the answer is usually yes or no. That decision point is based on some information. And so in XACML, it was some XML document somewhere that described the entities that we're trying to access, described the user, and then we could retrieve that information to make our decision. And there are other points about retrieving, about administering those policies, because you have to write those XML documents and change them and so on. And 2003, so tons and tons and tons and tons and tons and tons of XML. So terrible, terrible time. But the concepts are good. Thinking about authorization in terms of enforcement, decision, information is good. So in the realm of Spring Security, inside your application, you have Spring Security and you're using it. The policy enforcement point is going to be the three things we've discussed, right? So we have a request level security, and then method level security, pre-authorize before we execute, or post-authorize or post-filter after we execute. For choosing the enforcement point, we've discussed the heuristics. Usually you want to do it as soon as possible, because you do less work and you're open to less attacks. So if you can do it at the request level, do it at the request level. If you can't, because you need to read the body, then pre-authorize. If you need the return object, then post-authorize. And you can combine them. You can have all three of them. This is fine. You can have multiple enforcement points that enforce different policies as well. The decision point is in a Spring Security application, is in your .access or .hasRole or .something on the request, so in here, and in your pre-authorized, post-authorized methods, so the Spring expression you have in here. So this can be a Spring expression language that we've learned gleefully about with our this and so on. So this, ooh, wow, English, amazing, come on, there we go. So this can be a spell, but it can also be a bean, right? You can reference a bean that's somewhere else in your application. So say here. But these things, they can also call external systems, right? So if you're doing XACML, maybe this is in your XACML XML hell here outside the system as well. And then there's the policy information point. So this is actually trickier than that, because the information, everything we've done so far in all of our example, the information was right there. There was no information to retrieve. The user has logged in, we know their email, so we can check their email. Sometimes in your company, maybe you have like several things. I have authorities that I have to fetch from LDAP for a certain subset of operations in my application. So maybe the policy information point is going to be the thing fetching stuff in that LDAP. But sometimes you may have problems where the information is lost or not correctly saved on login. So when I logged in as a user, I have my email, right? And so at the time of the login, I capture the email. But I don't capture the time of login. And maybe the time of login is important to me to make a decision. Or with the example we have with OpenID Connect, I want to take some claims and I want to transform them into authorities. So I want to make that information digestible for my system. And so you have to think how you can do it at login time. So I want to show you an example of this. In our app, this beautiful, beautiful application that's in debug mode. Continue. Please continue. Come on. Yeah, perfect. So run this without debug, otherwise it's going to be slow. Okay, here we go. Public page. Daniel is logged in. I now have an HTTP basic page. All right. And, oh, Josh is logged out. It's been too long. All right. I want this page to only be accessible through HTTP basic, not through the browser like this. So the way I would do this is, same thing that we've been doing since the beginning with the request level. At the request level, we can know. So we do auth z, so can only access through HTTP basic. So the first thing is I must be able to log in. So log in or authenticate, it's not really a login, with HTTP basic. We do that HTTP basic with defaults. So this will add some more filters to my filter chain, and now I can make requests. I can make HTTP requests, AT private, and then I can pass auth Daniel PW, and then I'll do it for both so we can see that. So I can get the private page over HTTP without a form by passing this --auth in HTTP or --user in curl, and it adds this HTTP basic authentication, which has this super secret thing, right? So echo this, a very secure header, base64 code, right? That has my password in clear text. So now I can log in both ways. Great. So now I'm going to make an authorization decision. Auth z request matchers. There's an endpoint called HTTP basic. And I want to decide something about, decide that only HTTP basic can come through. So we have an auth supplier, and we have a request context, right? OK. So in here, I'm going to return something, authorization decision, let's say true for the beginning. And so the auth supplier, I can get the authentication, and I can log it to the console. Log, info, let's do passport. There we go. Passport, and then we do the authentication. Okay. So I'm not making a decision here, I'm just observing the user who's making the request. So let's clean up the logs. Here we go. And then refresh this page. And now I have a log here and says, well, the user logged in, and I have a username password authentication token. And I have a principal, and it's a demo user. So that's Daniel. Here's email and authorities, and then I have some roles, right? And some credentials that I'm hiding, because you should not be logging credentials. They're actually null if you look at what's happening in here, but we will not show you what's in credentials. OK, sure, we have Daniel here. What about if I do this again with HTTP basic? So do the same thing. Go here and say, oh, OK, it's a username password authentication token. So the same authentication object, the username, the principal, it's Daniel with email danielexample.com and credentials and so on, and then the roles, user and speaker. And then that's it. So I can't tell them apart here, because the information that they logged in using HTTP basic was lost, because in Spring Security, we thought that was not super important. So you want to write some code to capture this information. And so to do that, you have to take a look at the principal authentication. So you can make your authentication object have special authorities. You could shove in here like a granted authority that is not a role, but that is like a form or login type. To do that, it's a lot of code, so we're not going to be showing that. There's also a very useful thing here, which is details. And the detail says stores additional details about the authentication request. It might be an IP address, certificate, and so on. And so in here, you'll notice this is an IP address. This is the IP address of the user who logged in. But we're not using that IP address in our app. We could replace that with whatever we want. So we want to set the details when the user logs in. So let's create that. In the security configuration, that's fine. We're going to record, since it's an object, I can make anything I want. and it's going to be like a login info. Login info. And this one will have, let's say, we'll do an enum, login type, sure, type. There we go, which has form login. I can log in with form login or HTTP basic. And so it had a login type, and then it will have, what can we capture? A collection, like let's do a list of string headers that were passed when I logged in. And then maybe we can capture int content length, the content length of the request. Why not, right? So I can capture this information. The way I do it, I take this form login and I configure the mechanism for form logins. So instead of doing T here, I'm going to give it a name. Let's see, form login. And in here, when you look at what's possible, it happens to be in alphabetical order the first authentication detail source. It's the thing that transforms a request into authentication details, so the details of the authentication object. So this one takes a authentication request and returns whatever you want. So in here, we can capture that. We can do return new login info. So we're logging in with form login. Let's capture form login. And then we want the headers. So the headers, their request get header names. Header names. This is a beautiful enumeration. So we do collections.list of header names. Okay. And then we need to pass the content length. Why not? Content length, right? And then, oh, you know what? We can also do instant login time. We mentioned login time, so why not login time? Do that. Okay, great. And then instant.now. All right. And so when I log in with form login, I capture this information. And I'm going to do the same for HTTP basic. So when I authenticate, when I send a request with HTTP basic, I'm going to capture. And so this one takes a request, and it's going to do basically exactly the same thing as here. Boop, put it here. And then what's different is now the type is HTTP basic. Okay? By doing that, when I log in, so I need to log out here and log back in to capture this information. When I log in now, Daniel PW, I go to private. So if I take my logs, I clean them up, and I go to that HTTP basic page, right? You'll see that the details are of type login info, and they contain stuff. Oh, here are the headers that Daniel passed when they logged in. So host can decide on user agent, and they sent content length. So now I'm leaking private information that he sent the username and a password, and that was 130 bytes. And he logged in at that time. And if I do the same with HTTP basic, Daniel PW, boop, then in that case, is that happening? I'm not sure. Oh, I need to call HTTP basic, of course. So here we want to call HTTP-basic, right? And so, is this not logging for some reason? Let's see, HTTP basic, form login. I think I don't know, it selects the same thing. Oh, look, when I select a word, IntelliJ has very different colors, and so I can tell them apart. Anyway, so in HTTP basic, I have HTTP basic, and we can see there's just a few headers that were sent. And the content length was -1 because there was no body. So now I can make my authorization decision in here. I can say, well, if the authentication get details is now a login info. Yes, login info, right? Yeah, fine. I trust that always do it. And then authenticate, it's not authentication, but login type equals, we want HTTP basic only, right? And so this one would be login info. So now I can check what was captured at the moment of login. And then I can make my decision. So now, if I go here and I refresh, ooh, I get a 5. Oh, yes, because, wait. Unnamed module cannot be cast to class login info because it's private. Get details. authentication supplier.get login info. Does this need to be public? Maybe. We'll see. Try again. Try again. Class cast exception. Oh, because it's the wrong one, so probably need to log out again. Oop. All right, try. Go to private. I was anonymous. For some reason, not for some reason, but I changed the nature of the authentication object, so I got logged out. Try again. Okay, this time 403, because I logged in with form login. And with HTTP basic though, in here, poop, this one passes. I am allowed to log in here, because when I did the authentication phase, I captured that information. And that's a pattern you're going to apply a lot. And it really depends on what you're doing exactly. So for example, someone asked me about OIDC. I don't know if you've read my mind, but I have a OpenID Connect thing running. So I have a DEX identity provider running to log in with SSO. So I'm going to add SSO quickly here. Let's see, pom.xml, this one. So I want to log in with auth to log in. So org.springframework.boot, spring boot starter auth to login. Come on, auth to dash login. Oh, IntelliJ, please be kind. All right, let's see. Spring boot starter client. There we go, not login, client. Here we go. So I add this dependency. Then I need to connect my application to this identity provider that's running. I'm going to create a profile for that, call it SSO, so that I don't have to have SSO. And so this is Spring Security auth to client. We're going to have a provider, call it DEX. It's running at this URL, localhost 556. So this you would find in the Docker Compose that uses that my app uses to run DEX. And so here, client name, this is going to be DEX IDP, and then I need a client ID and a client secret. Client secret. So this is internals of how you do SSO. And then we pass some scopes, OpenID, email, profile, like the classic. And so this client ID, client secret, I don't remember them very well. So they're in my config here. So I have some clients, and the ID is DEX client ID. The secret is DEX client secret. Okay. So usually this you would find in your identity provider. So maybe you go to Okta or to Google or to Microsoft Entra, and you create that. So I have this profile now, and I want to turn on login with SSO. So I go to security configuration here, and I add login with SSO. HTTP basic is here, so SSO login. To do this, I would do auth to login with default. So in that case, it will add it in every profile. So I want to add it only in the SSO profile. So in here, I can check the profile before. So if the environment bean matches the profile called SSO, then in that case, I configure http.auth to login. So I only do SSO when the profile is SSO. I think my IntelliJ is already configured to use the SSO profile. Let's see. Command, come on. All right, what? Edit configuration, this one. So it's already using the SSO profile, so this should work. So let's start it again. Oh, probably re-import Maven. Do again. Okay, so now when I go to the main page, I go to private. Now I have a new way of logging in with my DEX identity provider. I can type this. So I have a new user here, password, grant access. And so I can log in. So if I go to the auth page we created, in here, we see this is now an auth to authentication token. It's not a username password authentication token because the user logged in with their auth to or OpenID Connect client. So the auth page worked, but the private page doesn't work because my controller here everywhere, demo controller, in the main page, it expects a demo user, right? And that's not a demo user. That's a, what's it called? OIDC user, default OIDC user. So in here, to do this, it means at login time, so I could change all my code to handle these special cases one by one. Or I could, at login time, transform the data. So you can do that. And let's say we create an interface, because interfaces are cool. So let's say user with email. That's my interface. And this thing has an email, get user email, right? And so my demo user can implement this interface, implements user with email, great. And so it has a get user email already, I think, here. So we can say override just to be sure our types are correct. Great. And so now I look up everywhere that I use demo user, right? So demo user in demo user, that's fine. Authorization service. These I want user with email because I'm just checking the email. Sure. Demo controller has a lot of demo user. So let's see, demo user, demo user, demo user, demo user. So that's user with email. And do I have more demo users? Authorization service, that's just an import. The security configuration here has a demo user. So in here, we replace this with a user with email. So now we don't really care about the concrete type anymore. And I think that's it. Yeah, I think so. Maybe. Oh, we'll see if I've forgotten something. So now it doesn't change anything. So I need to change my OIDC user from Spring Security to something that implements that new interface. So I create that thing, demo OIDC user. This extends default OIDC user, and it implements user with email. So okay, we need a constructor for that. Oh, come on. It doesn't want to. Sure. So let's create a constructor. Let's create this one. So create that. This one has a OIDC user. So the thing that Spring Security creates for me, that's the base user that Spring Security creates. And I'm going to wrap it in my thing. So base user.get, what's the first one? Get authorities, right? Capture the get ID token, and then base user get user info. Beautiful. So now I need to implement this get user email method of the user with email interface, and the base OIDC user has a get email, but it returns a string. So now I'm going to turn that in an email object, parsing it. Okay. So this is now the class that I want to return for when a user logs in. How do I do it? You would have to go to the docs. I'm not going to show you that, but I'm going to create a demo OIDC user service, which extends OIDC user service. No, OIDC user service, this one, right? And then in here, we're going to override the method load user, which is the thing that Spring Security uses to parse the tokens and so on. And so this thing is a base user that Spring Security creates for me. And in here, I return a new OIDC, demo OIDC user. So I take whatever Spring Security gives me by default, same exact behavior, same exact implementation, and I just wrap it so that it's presented to Spring Security as a default OIDC user, and it's presented to my app as a user with email. So now, if the demo gods are with me, let's go to localhost 8080, let's go to private. I need to log out first, log out, fine. And then now I log in, admin@example.com, and then a super secret password, right? And then I go to the private page, and now I can go to the private page, and the private page works, and I have an email for a user, right? So I took multiple ways of logging in, and then I capture all the information I need for authorization in this one interface, which is called user with email, right? Okay, so when you're designing your authorization domain, you need to think really hard, what is the information that I care about, and try and model it, right? So it can be the claims that come in an ID token. It can be some scopes. It can be some data that is attached to the objects as well. And you want to know when is this information available to make sure it is captured, and you can, because sometimes you lose it, right? If you want to know HTTP basic login, you have to capture it at authentication time, right? So you need to, when do I have this data? Is it already captured for me? No, then I do it. Or can I transform it and use roles? So can I map some claims into roles so that my authentication is easier? And so if you have different authentication types, interfaces are great. We're not going to see all the details of how you can do that. It really depends on your login type. So really depending on the form of login you use, you may use different interfaces. Something you'll find everywhere is this authentication detail source. Authentication converter is also quite present, which takes an HTTP request, produces a authentication object. Authentication provider is another way, so go watch my YouTube talk and you'll see that. And then some abstractions have, some login methods have their own abstractions, such as the OIDC user service for OpenID Connect login, right? Last resort, a filter. Most of the time you don't need a filter, like 99.9% of the time you do not need a filter. Like, it's not because you learned of the filter interface today that I want to see you writing filters everywhere, right? This is the last resort. It's better to go to the docs, and the docs are extremely, extremely complete. So you've seen this method security stuff, right? We have a bajillion words here. If you're lazy, ask ChatGPT to find the information for you. But please, it's in here, right? So say, oh, we want to do, what's it called? OAuth 2, and then login. Sorry, I should zoom in. Right, oh, here's the advanced configuration. So, oh, here's all the things you can do with it. And so most likely the answer to your problem will be in the docs. It will require a bit of reading, but it will be much better than hacking something that's insecure in a filter. All right, good so far? Yeah? That's the hard part. This is usually where people start sleeping. Also, it's the second part of the afternoon. So, someone had questions about multiple security filter chain. That's a thing you can do indeed. So let's log out in here. I'm going to log back in as Daniel. And then, oops, Daniel. Actually, you know what? I'm going to try and go to HTTP basic. So here, I'm not logged in. I try to go to HTTP basic. Restart class loader. OK, fine. Let's restart. It's perfect. Oh, the HTTP basic assumes, I told you I told you it's always details is always this. So, of course, it's not. So, if that's the details, right, var, and then so if login info, instance of login info, and login info dot type equals HTTP basic, then return new authorization decision true, and then otherwise return false. Right? Type safety, friends. Don't cast. All right, so do that again. So I tried to go to HTTP basic, authorization denied because I didn't log in with HTTP basic. I am actually anonymous. I'm not logged in yet. And so I get redirected to the login page. Ah, cool. So I can log in now. I can access this thing. And then boom, HTTP 403, which is kind of silly now, right? I know that this endpoint, I will need to log in with HTTP basic here. Form login will never work. So proposing a form login for that page is not cool. It's not nice for users. So I'm going to log out again. So you should, if you want to do this, then you should configure your exception translation filter, which you do through this, right? Exception handling, exe, and then in here, it has a default authentication entry point 4. So the authentication entry point, we want to force HTTP basic. So Spring Security has a basic authentication entry point. And then in here, we want a request matcher. So path, pattern, request matcher with default, and the matcher is HTTP basic. So when someone tries to access HTTP basic, and they're not logged in, we're going to propose HTTP basic login to them. So try this again, HTTP basic. Have to compile first. HTTP basic. There we go. So now I get the beautiful Firefox form that comes in with HTTP basic. So by configuring exception handling. This gets complicated, right? Because now we have, for this rule, we have to configure form login, we have to configure HTTP basic, we have to configure exception handling, and we have to have a special rule for HTTP basic here. So now I have things in 3 places to enforce HTTP basic. This is where separating your rules in different filter chains when you have different endpoints or different shapes of requests is a great way of avoiding this kind of thing. So we've created a single filter chain, and that filter chain processes every request. But it's absolutely valid to create multiple filter chains. Security filter chain, and I'm calling it HTTP basic security filter chain. HTTP security, HTTP, right? And then throws exception, fine. Return http.build. So I want to put my rules about the HTTP basic endpoint in this filter chain. The way I do it is I do dot security matcher here. So I can put a string. In our case, it's a string, but I can also put a request matcher. Oh, if it has the special header, then I'm going to process it here. And so all the rules for HTTP basic will be in here. The way Spring Security decides which filter chain is applied, only one of them will be applied, is it takes them in order, and then it says, does it match? So if I go to /API and this one comes first, it doesn't match /API, so it tries the next filter chain, and this one is the catch-all, right? This one doesn't have any filter, security matchers, so this one will be applied to every request that is not matched before. But the order is important. If this one comes first, since it applies to every request, no other filter chain would be applied. So you need to say at order, and this one is a lower priority, or a higher priority, sorry, than this one. So order, I'm going to put 1 here. In Spring, if you don't define the order, you get the lowest precedence, which is the max value here, right? So if you just don't put anything here, integer, the max value, this one comes last by default. So if you don't put order. So this is fine. So I want HTTP basic to be handled here. So what does that mean? That means I want that all requests are authenticated. Any request authenticated, right? I can't come in without an authentication. I want to be able to log in with HTTP basic with default. And then maybe also I can say, oh, well, this one doesn't need sessions because the credentials are always presented in the header. So I can do session creation policy. This is a stateless part of my application. And so now I have all the rules for HTTP basic in here. And so I can come back and remove everything that is about HTTP basic that I don't need anymore. So now I can keep the default form login with defaults. I can remove HTTP basic from here, and I can remove exception handling. So now this login info and so on can go away. I recompile my application, right? So the main app still works the same way, Daniel PW, right? So you can still see, the profile and so on. I can still make HTTP basic requests to the HTTP basic endpoint. I get something. But now, when I click on this HTTP basic, the filter chain that is applied is the one about HTTP basic. So it says, you must log in with HTTP basic. And so I have my beloved HTTP basic form again. So this is a great way to avoid the interdependencies of exception handling and rules and detail source and so on. So if you have very different endpoints or very different requests because they have different headers or different content types or they have different origins, right? The server, the IP address of the client is different, so I treat them differently, then multiple filter chains is the way to go. It will drive down the complexity of your application, but public service announcement on this, please, I have seen this before. Do not create 65 filter chains in your application. This is actually worse, right? You have to find a commonality, what is really, really similar, put them in the same filter chain, and what is really different and separate them. Otherwise, this is worse, because then you get very complicated matchers to select which filter chain applies, and holding this in your head, it's 65 different beans, it's worse. Okay, any questions about this? The room fell silent. Yes? Does it also work for different ports? I do not know, but this in the matcher here, I think you should be able to do that. So here I put HTTP basic, but here you do a new request matcher. And so the request get a local port. This is the remote port, I think. The user that, so you can say, oh, if the request.remote port equals 1234, then I treat it, right? Provided that it's correctly visible in your application, because if you have a proxy and the proxy is doing the different ports, there might be subtleties in here, but you could definitely do it with this. So yes, I learned something. Thank you. All right, okay. I'm gonna try and not kill you for the last 23 minutes of this talk. Before we do access control models, I actually want to talk about testing, because it's an important thing that sometimes goes under the radar, and it's very sad, and it makes me really, really sad inside. So we've made a lot of authorization rules scattered across our application. It actually is a good thing to try and test them. So we're gonna do that. Because some people, I'm not gonna ask who, they disable security in their testing. This is the cardinal sin in security, right? You should be testing your security. It's a very important part of your domain. So let's do this. So we use auto-configure mock MVC. So mock MVC because we don't need a full web server. We inject a bean of type mock MVC tester because this is 2024 or 2025 now. This is not Spring Boot 3.2 anymore, right? So anybody, does everybody know mock MVC tester? Someone, yeah, a few people. This is, you could also have the bean called mock MVC, this one. Boo, this is legacy. Not this boo, scream. Yeah, this one, this little dude here, all right. All right, so don't use that one, use this MVC here, so I'm gonna remove that. And so let's say the public page. First, the public page is easy. We do MVC, get. So this one has a nice Fluent API. The URI is slash. We exchange, we get a response, resp. And we integrate with AssertJ to have nice assertions. So import method, AssertJ, response. Has status 200. It's successful, and also maybe, oh, let's do it fluently. And then we want the body text to contain totally public, I think my public page has, right? So let's see, and then go to the public page. This page is totally public. All right, so run that. It should work. Public page is public. Haha, easy. All right, so now the complicated part is about the private page. Duplicate this, and then let's say the admin page. Let's go all the way to the admin page. So I want to go to admin, admin page, and anonymous. When I'm not logged in, then this it's a 300. I'm redirected, and then the redirect URL ends with /login. Right. So when I'm not logged in, I try to go to admin. It redirects me to login. Amazing. Aha, okay, so now admin page, admin. So I want to be admin, I want to have the role admin. So with Spring Security Test, one thing you can do is with mock user, and then you pass a fake user here, which has a username, maybe test user, fine. And then it has roles. So in here I could say, oh, they're a user, and they have the admin role. And so with that, we should get a has 2xx, and then body text, I don't remember, contains, I'm sorry, I can't remember what I have in admin. There we go, admin 403, haha, because I'm not logged in. Oh, I'm not admin, hey, Josh is admin, okay, Josh. And Josh is not logged in because timeout, fine. I'm sorry, Josh at example.com. All right, so I'm sorry, contains I'm sorry. So this is going to be a problem because this creates a user details, a username password authentication token with a Spring Security user, puts it in the context. And so it is 200 successful until it explodes because we want an email. And the Spring Security user has no email. So this thing here, blah, 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 request processing fail, null pointer, get user email. User is null because it's not a user with email. It's a Spring Security user. So we have to be smarter about this. One thing we can do is use the real users from our database. So find them by name. This loads Josh from the database, right? So by doing that, in the test, it uses a real implementation and it works. You can also specify a user details service bean name, test user details service. So you can create your own test beans. And so we're going to say this is test user. Okay. And we want that user to have test@example.com. And so we need to return this thing, this bean, so we can add it to our test configuration. Test configuration. So we add a configuration for our tests. Static class config return. This is a bean, sorry, of type user detail service. User detail service, and it's going to be our demo user detail service, really. Demo user service, great, and return new demo user service. So we don't need to use the real users. Now we can create a new demo user, and the demo user is test user, and the password is ignored. We don't use the password here, and their email is test@example.com, and then the roles, they must be at least admin, right? So I can make users, not OIDC. Wow, oh wow. Demo user details service. Here we go. This is a demo user. Hey, right? Demo user details service. No, demo user details service. Hey, here we go. First try. And so the name of this should be test user detail service. I'm going to copy that here. And so now this test will load test user from this fake test user detail service. Do it here. Probably got the names wrong or something. I'm sorry, test@example.com. There's a new line in here. So, okay, fine. Contains, and then contains this, right? Don't count the new lines. Easy. Ha. Gotcha. All right, so that's one way of doing it. The other way in here, test, so admin page with authentication. You can also do something a bit similar here, but instead of creating your user detail service and referencing stuff by string name, you can create a demo user here directly, demo user. So actually I'm going to steal that one so I don't have to retype it. I can create my demo user, right? So one too many. So that's my user. And then I can create a new testing authentication token. So this is an implementation. Come on, we'll see it. So here's a principle. The principle is the user, credentials, they can be ignored. And then the authorities is the user get authorities, right? So this is an implementation of authentication, right? And I'm not using a username password authentication token here because I don't have a password. The password, the credentials, they could be null really, right? They're ignored. So I'm using an authentication object that's just for testing, but it's fine. It has the correct principle. And then I can shove it in the request with, and in here, Spring Security gives you stuff that modifies the request. Security, mock MVC, request post processors. Talk about Java naming. And we can put the authentication in the request. So the great thing about Java naming is you go here, right? You do Alt Enter, and then static import, boom. Oh, that's beautiful, right? Okay, and so with this, it is added to the authentication in the security context, and it's available. So one more thing you can do, but we have 15 minutes. I want to leave room for questions and maybe go over authentication methods. This with user details here, or with mock user, It's actually not super complicated. You can write your own annotation, and the thing you need to write is this security context factory. So you can copy the code in with mock user here. And the only thing that this does is it creates a user based on your annotation and then puts that in the security context. So this is completely feasible for you. If you're going to use the user with email, you can do with, so maybe user with email, it's possible to do email equals test@example.com. And then you can put some roles that you can do, right? If you have custom authentications that you want to be using, do that. I'm not going to demo it here, but after the presentation, if you want, we can go over this. All right, so we're done testing. We have great tooling for that. So do not disable your authentication. I will find you. I will know where you live, and I will call you over the phone and breathe heavily. I know what you're doing. No, do not disable your security. Please test your security. The thing that you cannot test with this is the authentication part. This bit assumes the authentication has happened and the correct authentication is in the context. If you want to test the thing that happens at authentication time, so for example, extracting information, then you have to do it with a full non-mock MVC test, right? A full running server behind that. Do you have questions about this so far? No questions? Okay. All right. So maybe let's go about access control models a little bit. We'll maybe not go through the demos too much because I see people are falling asleep and leaving now. In access control, there's the old school access control lists, which we don't do anymore. Spring Security has support for access control lists, but it hasn't changed in years, so that's not what we would be doing. There's basically three modes or three models for modeling authorization or access control: role-based, attribute-based, and relationship-based. So role-based is easy. It's already supported in Spring Security. It's what we've seen, right? So the users in our security configuration, we give them some roles, right? User, speaker, and so on. And then we can check if they have the role. So maybe here there's a has role. So this type of authentication usually requires some kind of hierarchy. So, if you're an admin, you're also a user, right? Or if you're a executive, you have access to this and that. And so this is modeled in Spring Security. You can do that. It's called a role hierarchy. And then you can return a role hierarchy implementation. So in here, you can do it from a string. In here, magic string like this that says role, say the speaker implies the role admin, maybe, right? And then maybe the role admin implies the role user, something like that. So by doing that, now, remember, Daniel is a speaker, so that means that implies the role admin. So in here, go back. So I'm Daniel, and now I go to admin. I can't see the admin page because the role speaker implies the role admin, so I have the role admin. This is fine. You can also, if you don't like magic strings, you can also do a role hierarchy implementation with default role prefix or with role prefix if you want, right? This is how the roles are recorded in authorities. This, and then you can say the role speaker implies admin, and then the role admin implies user. That works as well. Oops, there we go. Something like that works as well. So it's fairly simple, but then as your authorization model, and it's well supported, right? But as your authorization domain grows, suddenly you have stuff like, now I want to be able to see the shipment that are in my name, but not other people's name. And that doesn't really fit into the roles, right? Then you start getting into roles like, am I a viewer? Am I a reader? Am I a admin? Am I a deleter? And so you have an explosion of roles, and it's not it's not manageable anymore. This is the sign that you should get out of role-based access control. You can keep some of it, but then add new things. And so the other options you have are attribute-based access control. So this is says when I have an authorization decision, I have a user, and the user has attributes. So the roles are attributes, but their email are attributes, their groups are attributes, their whatever, their claims in the token are attributes. Then the object itself has attributes. So maybe, you know, I have a shipment, and the shipment has an owner, and the owner is an attribute. And maybe the context, the request context in which I'm doing, it has attributes. Oh, it was HTTP basic, and so on. And so I make decisions based on this. So you can use stuff in your app. So XACML does that a lot. But the sad thing about XACML is that if you go to Maven Central and you look for XACML for J, right, XACML for J core, the last release was in 2021, and the one before that in 2014. So if you start a project with XACML today, I have bad news. Today, someone came and said, oh, we're going to use Open Policy Agent, OPA or OPA, openpolicyagent.org. So this is a flexible system that lives outside of your app and in which you model your basically your domain, right, to your authorization domain. And so you can search, and you can, in here, you can implement RBAC. So if you look for RBAC, you'll have stuff. You can implement ABAC, attribute-based access control. And so, oh, here's Alice. Alice has 15 years of tenure. She's a trader. Here's the tickers that we can try. So Microsoft is on the NASDAQ. Here's the price, and so on. And so, oh, default allow false, and allow if the user is a trader and it's in the NASDAQ and it's less than $2 million that are traded, right? And you can do 5 million if you have more than 10 years of tenure. So you can model that in a system outside. And so every time you make a request, your system would call that external system. So that means you need to maintain the attributes in your app for what you call it, for your domain, but you also you need to maintain some attributes in your OPA system to be able to compare stuff as well. And then the last one is RBAC, relationship-based access control. So this one is the cool kid on the block. It came out in 2018, I think. So this was invented following a paper by Google called Zanzibar. And Google have a very specific authorization problem that you see in Google Drive, right? You know, I have a folder that contains a folder that contains a folder that contains a folder, and then in there I have documents. Who has access to document number 3 here? So I have the creator of that, and then the owner of the folder, but the owner of the parent folder as well, and the owner of the parent folder. So these are relationships between objects. And I don't know, I find it fun, so I'm going to show you what it looks like. So I have an implementation of that in OpenFGA. So OpenFGA is a project by Auth0. And so it's open source. You can run it. It lives in an external system as well. And it describes relationships between your entities. So here's we go, 3000 playground. Is this running? Yes, this is running. Required only, that's fine. And so this is zoomed out a bit too much. But in here, I describe my authorization system on the left in here. So I have users. Users, they don't have attributes, they're just users. And then I have organizations. Organizations have members. Members are of type users. They may have admins. And they may have a parent or parents as well. So an org may have a parent, and that parent is an org. And then admins, they're either users or the admin from a parent organization. Have shipments. Shipments are in an org. And then they have relations of viewers. So who are the viewers of the shipments? They're members of the organization or admins from the organization, which are admins from the org or admin from its parent or admin from its parents. And so then you enter tuples in here and you say, oh, okay, I want to say a user Daniel. I already have Daniel here, but I could say user Bob at I probably have Bob already. So Daria at example.com, and then the I moved out. All right. The relation is, so Daria is a member. Oops. Member of, I can do it. Member of org example.com, right? And this is how it describes stuff. And then you can say, oh, I have org example.com, and the relationship to, it's the org for the shipment with ID 42, right? And now I can test stuff about that. So you can do it with assertions here, and then you can say user, so the user is user Daria at example.com. Is she a viewer of the object shipment 1? Or we did 42, I think, right? At this, and then I can do another one. User Carol at Alice at corp.example.com. Is she a viewer of shipment 42, right? Save, right? Cancel this. And then I can test these. Oh, no, I don't want to add. I can test these and say, oh yes, this one is true because shipment 42 is in the org, blah, blah. And then Alice is in corp, so she doesn't have access to the org. And so in here, you can do the same queries in here. Is Daniel, user Daniel at example.com related to shipment 42 as viewer? So can Daniel view? Yes, through that tree. And what's fun is that you can do stuff, since this is a graph of relationships, you can do it the other way around. Who is related to shipment 4 as viewer? And so here it will give you all the graph of the relationships. And so when you dive into it, well, the viewer, we have the organization. The organization is corp.example.com. And so the two users of corp.example.com have access, but also corp.example.com has an admin through the system org, and that's Josh, right? And so you would call out to this in your system in here, right? If you wanted to do something, then you would do, right, like auth z.request matchers, shipment, ID, right? And in here, you do an access that will check, make an HTTP request, and get an authorization decision by the external system. All right, since we only have a few minutes left, I want to tell you a few things. So first, you've remained here until the end. That is very impressive. Bravo to everyone here. Bravo. Second, you are security conscious professionals, right? We've done authorization for 3 hours now. So when some random dude on stage gives you a QR code, what do? You scan it, of course, right? What could go wrong? In truth, this is the feedback form for, come on, get out. There we go. This is the feedback form for this talk, right? And so if you take 5 seconds to give me feedback, it will make me very happy. If you take 25 seconds to type stuff about what you liked, what you didn't like, what you understood, didn't understand. So stuff like, oh, I don't know. It was fun. Only 2 people fell asleep, and then they laughed at my jokes, I think. Right? So give me feedback here. If you don't have any idea what you could do, right, just don't let your neighbor influence you or give you an idea of what you should be doing. Just decide on your own, right? And then once you've decided, make your pick. All right, and so, give you the QR code again, right? Security, scan it, beautiful, beautiful. Phones, amazing. More stuff, more QR codes. So if you want to see the Spring Security intro on YouTube, 45 minutes, it's here on the left. If you would like to hear my thoughts and the thoughts of the Spring community, so the core maintainers, contributors, friends, public speakers who do Spring stuff, I have a starter pack on Blue Sky. You can open an account on Blue Sky and follow 60 very nice Spring people already through this, right? And with that, if you want to see more of this, I have normal talks on Thursday. Passkey's passwordless login on Spring Security, and then MCP, because we only have 15 MCP talks at DevOps this year. So one more, why not? And with that, thank you for your attention, and I hope I will chat with you in the hallways. Thanks.